The universe is a vast, echoing silence. A silence so profound it swallows everything: sound, time, even meaning. And yet, sometimes, if we listen closely, truly, deeply, we can hear it whisper. Not in words, not in any language we know, but in signals. Faint pulses. Glimmers of rhythm from the farthest reaches of space. Signals that travel across unimaginable distances. Across ancient galaxies. Across the ruins of stars long gone. And sometimes, when the timing is right, one of those signals reaches us. In early 2024, something extraordinary happened. In the remote mountains of British Columbia, Canada, a team of astronomers operating one of the most advanced radio telescopes in the world, the CHIME Observatory, detected a signal unlike anything they had ever seen. CHIME, the Canadian Hydrogen Intensity Mapping Experiment, has been scanning the sky since 2017. Its original mission was to map the large-scale structure of the early universe by listening to the faint hum of hydrogen. But along the way, it became famous for something else, detecting strange, brief, powerful blasts of energy known as fast radio bursts, FRBs. FRBs are among the most perplexing phenomena in astrophysics. They last for just milliseconds. They come from billions of light-years away. And they're astonishingly powerful. In the blink of an eye, they emit more energy than our sun will in an entire year. Some happen only once, never to be heard again. Others repeat, but without warning, no rhythm, no schedule. They defy explanation. No known celestial object, no star, no black hole, no planet, behaves the way these signals do. They're like fireworks going off at random in the night. But the signal CHIME detected that night in February was different. It wasn't the strength of the signal that stunned the astronomers. It wasn't even its distance. It was something far stranger and far more unsettling. This signal repeated. Not occasionally. Not randomly. It repeated precisely. Every 22.4 days. Like clockwork. No fluctuation. No deviation. A pulse, like a cosmic heartbeat, ticking off the days with mechanical accuracy. The team was shocked. They ran diagnostics. They checked and rechecked their instruments. Could it be a software glitch? Local interference? Human error? They ruled out every possibility, one by one. The signal was clean. The origin was astronomical. It was real, and it was out there. What made it even more incredible was its journey. This wasn't some local noise. The signal had traveled across hundreds of millions of light-years. It had crossed intergalactic space. It had passed stars, planets, gas clouds, and black holes. It had been traveling for longer than human beings have existed. And yet, at that moment, it found its way to Earth, to CHIME, to us. The discovery sent shockwaves through the astronomical community. Word spread fast. Within hours, observatories around the world turned their attention toward the same coordinates. From Chile to Australia, from South Africa to Europe, scientists were listening. And what they heard only deepened the mystery. The next burst arrived. Right on schedule. Then another. And another. Every 22.4 days, exactly. This was unprecedented. FRBs were supposed to be unpredictable, chaotic, wild. But this one obeyed a schedule. This one kept time. It didn't just challenge our theories, it shattered them. Some began to wonder, could this be artificial? Could it be a signal, a deliberate one, meant to be heard? Was someone, or something, trying to get our attention? At first, most dismissed the idea. After all, there are plenty of natural systems in the universe that produce rhythm. Pulsars, for instance, rotating neutron stars, can emit extremely regular pulses. But even they don't match the profile of this signal. The 22-point-per-day cycle didn't fit any known pattern of rotation, orbit, or decay. Whatever was causing it, it wasn't anything we'd seen before. It was new. And so, what began as a strange little data spike in a Canadian lab became the center of a global investigation. Scientists began working around the clock, mapping the signal, modeling the source, digging through years of old data to see if this signal had been hiding in plain sight all along. Because now they knew when to expect it. Now they could prepare. And with every new burst, the mystery deepened. This was no longer just a curiosity. This was a clock ticking in the dark. A perfect rhythm, far away, untouched by time, untouched by chance. A message, perhaps, or maybe just a mechanism. But either way, it was real. It was regular. And it was reaching us, again and again. The universe had whispered. And this time, we heard it. The origin of the signal remained a mystery. But its implications were impossible to ignore. In the world of astronomy, there are blips and glitches, stray spikes in data that amount to little more than noise. But this wasn't that. This was a beacon, structured, periodic, clean. It was unlike anything astronomers had seen before. It hinted not at randomness, but at design. At predictability. At purpose. And purpose, in the cold logic of science, is a very dangerous word. What Chime had uncovered wasn't just another fast radio burst. It was a recurring event, a consistent transmission spaced across time, repeating with mechanical precision. A pulse from the stars, unfaltering, unmoved by distance or decay. This was not noise. It was a signal. And the world began to take notice. The media, of course, exploded. Headlines screamed across screens and papers. Alien contact. Proof of extraterrestrial technology. Has Earth been pinged by intelligence? To the public, the answer was obvious: something out there was talking to us. But within the scientific community, the real excitement came from a very different place. Not fear. Not fantasy. But curiosity. Deep, unshakable, methodical curiosity. The team at Chime knew they were onto something unusual. But to understand how unusual, they needed to go backward before they could go forward. They began digging, not just through their own archives, but through data collected over the past 2 decades by telescopes around the globe. Data that had been stored, logged, and forgotten. Petabytes of cosmic static, waiting to be heard again. And buried within it, almost invisible, almost laughably faint, were whispers of that same 22-point-per-day pattern. Echoes of the same signal, too weak to have been noticed before. Scattered like breadcrumbs through time. Intermittent, fragmentary, but unmistakable. The signal wasn't new. It had been there all along. Hiding in plain sight. This revelation changed everything. Because now, the team had a timeline. Now, they could begin the real work, tracing the signal back to its origin, and uncovering whatever, or whoever, was behind it. The first step was process of elimination. Astronomy, after all, is often the science of ruling out the impossible until only the improbable remains. The first suspects were the usual culprits, known celestial objects that emit radiation on predictable intervals. Pulsars were at the top of the list. These are spinning neutron stars, incredibly dense remnants of supernovae, that sweep beams of energy through space like cosmic lighthouses. Some of them are so regular they rival atomic clocks. But the spacing was wrong. Pulsars emit pulses every few seconds, sometimes milliseconds. Not every 22 days. Not from this distance. Not with this power profile. Next, the team turned to magnetars, a rarer and more extreme class of neutron stars. These magnetic beasts can release sudden, dramatic bursts of energy that outshine entire galaxies for brief moments. But magnetars are erratic. Wild. Their bursts are triggered by starquakes and magnetic reconnect ions. They do not follow a rhythm. They are chaos embodied. And this signal was anything but chaotic. That left the next, more mundane possibility, and perhaps the most disappointing one. Could it be man-made? Could a rogue satellite or Earth-based emitter have generated the signal by accident? It wouldn't be the first time. After all, in 2015, what was believed to be a new type of FRB turned out to be, quite embarrassingly, the signal from a microwave oven in the observatory's break room. The Chime team didn't rule it out. They tested for all forms of known interference, satellites, ground stations, aircraft, even reflections off the moon. But one by one, they were eliminated. The signal came from the cosmos. Its frequency was consistent with cosmic sources. And the rhythm was otherworldly. The community's excitement now reached a fever pitch. Theories flourished. Debates raged. Could a natural object really emit such precise pulses over such long intervals? And if not, what then? To answer that, a new strategy was put in place. Observatories across the planet would synchronize. They would all listen at the same time, at the same frequency, on the same day, to catch the next expected burst in real time. If the signal repeated again, on cue, at the same strength and timing, from multiple locations, there would be no doubt left. It would be confirmed. And so, they waited. March 6th for 13 a.m. Universal Time Coordinated. The date loomed like a countdown to launch. In labs and observatories around the world, researchers sat ready. Monitors were watched. Logs prepared. Notebooks open. A global audience of scientists held its collective breath. And then, it came. Right on time. Not a second early. Not a second late. The pulse hit every observatory monitoring the coordinates. The same frequency. The same waveform. The same profile. As if the universe itself were keeping time. It was no longer a fluke. No longer a chance anomaly. This was real. This was reliable. This was something. And then came the question no one could ignore any longer. What kind of cosmic mechanism ticks like a watch? What engine of nature runs with this level of precision? What system, in all the known universe, could behave like this? Was this a new kind of star? A previously unknown type of cosmic object? Or was it something else entirely? Something built? Something intentional? The signal didn't answer those questions. But it didn't have to. Because now, astronomers weren't just looking. They were listening. And they would keep listening. Because whatever was out there was still ticking. Now that the signal cycle had been confirmed every 22.4 days without fail, the mystery didn't fade. It deepened. Because the universe, for all its brilliance, rarely follows a schedule. Nature is a playground of entropy. It dances in chaos. It pulses in randomness. Stars flicker. Galaxies spin. Black holes rage. Everything is in motion, yes, but never like this. This signal was different. This was order. And in that order, there was something deeper. Something ancient. Something intentional. The signal itself was fleeting. Barely a whisper in time. Just a few milliseconds of radio noise. Enough to register. Enough to verify. But not enough to understand. Yet with each recurrence, more pieces of the puzzle emerged. Each pulse brought new clarity. Each arrival added data points. And gradually, from the scattered fragments, a picture began to take shape. This wasn't just a repeating signal. It was a structured one. Each burst didn't simply repeat in time, it repeated in architecture. The same profile. The same shape. The same sonic signature. But beneath that surface, the scientists began to notice something strange. Substructures. Modulation patterns. Harmonics layered within harmonics. Frequencies nested like Russian dolls, hidden within one another. It wasn't noise. It was composition. Like a fractal, endlessly complex, yet built from simple, recursive rules. A signal wrapped inside itself. Not chaotic. Not random. A message? Perhaps. Or a process. A code. A form of language not made of words, but of waves. That was when things escalated. The discovery crossed the boundary between astronomy and something more profound. The world's top minds were brought into the conversation. Not just astrophysicists, but cryptographers, people who spent their lives unraveling encoded meaning. Mathematicians, trained to find structure where none should exist. And even linguists, experts in pattern, recursion, and the deep roots of communication. Some argued the signal had all the hallmarks of a message. Repetition. Modulation. Structure. But if it was a message, then who was the sender? And what were they trying to say? This brought the search for extraterrestrial intelligence, SETI, back into the spotlight. An organization long teetering on the fringes of mainstream science. Dismissed by many. Quietly working in the shadows of larger observatories. Suddenly, it was at the center of global attention. SETI's telescopes locked onto the coordinates provided by CHIME. Their sophisticated signal processing algorithms were tuned precisely to the incoming frequencies. Their goal was simple: find anything, any irregularity, any modulation, any spike that might suggest intelligence. And not just any intelligence, but intention. What SETI looks for is very specific: symmetry, encoded repetition, prime number sequences, non-random modulation, patterns that don't occur naturally, things that scream, "This was made, not born." The signal had modulation. It had symmetry. It had order. But was it communication? Or was it computation, a purely physical system operating in ways we simply don't yet understand? Back in the realm of astrophysics, a more grounded theory was gaining traction. Perhaps this wasn't a message at all. Perhaps it wasn't artificial. Perhaps the signal was the byproduct of something real, something natural, something astronomically rare. As more observatories joined the effort, the signal's point of origin was traced with increasing accuracy. The Very Large Array in New Mexico, among others, triangulated the source. It was coming from a distant galaxy, 500 million light-years away. In the cosmic ledger, it was a speck catalogued as SDSS J015800.28+65 for 253.0. A name only a database could love. But it held the answer to the signal. Inside the galaxy was a binary star system. One star was dying. The other was invisible. Undetectable invisible light. But massive. Dense. It didn't emit. It devoured. A black hole. And so a theory emerged. Perhaps this wasn't a transmission. Perhaps it was a flare. A flash of energy released each time the system reached a precise orbital configuration. Every 22.4 days, the companion star swung into the perfect alignment, and the black hole's magnetic field allowed a jet of radiation to escape. Like the beam of a lighthouse passing over Earth for just an instant. Not a message, then, but a mirror. Nature, reflecting its processes in our direction. Still, not everyone was convinced. Many scientists pointed to the complexity of the signal. The layered structure. The near-perfect repetition. Could nature, as we know it, truly produce something so elegant? So precise? Could a system birthed in supernovae, ruled by gravity and magnetic fields, generate a signal indistinguishable, in form, if not in meaning, from intelligent design? Because now, after months of study, the signal had repeated not once, not twice, but 7 times. And each burst arrived on time. On schedule. Down to the second. Scientists were no longer observing an event. They were watching a clock. A timekeeping mechanism. Ticking away somewhere in the dark. They had a pattern. They had a source. They had data. But they still had no answer. And so the question grew louder. Not just among scientists, but in every person who looked up at the night sky and wondered, could this be the voice of another mind? Could this be the echo of some ancient intelligence, using gravitational fields as its medium, speaking not in language, but in light? Or was this the universe itself, performing a trick of physics so rare, so perfect, that it only feels like a message? Was this an accident? Or was it deliberate? The signal did not say. It only repeated. By now, the pieces were finally beginning to come together. After months of observation, speculation, and global collaboration, a coherent picture emerged, not just of where the signal was coming from, but of what it was. The periodic radio pulse wasn't just an anomaly in space. It was the heartbeat of a dying system. A rhythmic flare sent out by a binary duet, a pairing of 2 stars, one long dead, and the other spiraling toward its own destruction. Binary systems, contrary to what most people imagine, are not rare. In fact, they may be the rule, not the exception. Most stars in our universe are born as twins. They orbit each other for billions of years in a delicate gravitational balance. But balance doesn't mean permanence. Stars die. And when they do, they don't simply wink out. They transform. They collapse. They become something else entirely. Sometimes, a star collapses into a neutron star, a ball of ultra-compressed matter, just a few kilometers wide, but denser than anything we can replicate on Earth. Sometimes, if the star is massive enough, it collapses even further into a black hole. A region of space where gravity is so strong, not even light can escape. An object so dense, it warps time itself. In the case of the signal we had been tracing, that seemed to be exactly what had happened. A stellar corpse, a black hole, sat silently at the center of the pattern. Small by black hole standards, but no less terrifying. It wasn't alone. Locked in a decaying orbit around it was its partner, a still living star. Still burning. Still holding together, for now. But the proximity was fatal. The gravitational pull of the black hole was relentless. Over time, it began to siphon off its partner's outer layers. Not all at once, but gradually, steadily. Gas from the star spiraled inward, forming a glowing halo of plasma, an accretion disk, around the black hole. That disk wasn't passive. It was violent. Matter heated to millions of degrees. Magnetic fields twisted. Pressure built. And then came the event that changed everything: relativistic jets. Under the right conditions, instead of swallowing everything, black holes eject matter at nearly the speed of light. Twin beams of plasma and radiation, focused and furious, fire out along the poles of the black hole. We still don't fully understand how. It's one of the great puzzles of high-energy astrophysics. But we know it happens. And when one of those jets happens to be aimed directly at Earth, even for just a fraction of a second, we detect it as a fast radio burst. But this wasn't random. This wasn't accidental. The bursts didn't come whenever the black hole felt like it. They came on schedule, every 22.4 days. Why? The answer lies in orbital geometry. The neutron star, or dying stellar companion, and the black hole were not aligned in a fixed direction. Their orbits precessed. Tilted. Like gears turning inside a cosmic machine. And once every 22.4 days, the angle was just right. The jet, normally sweeping elsewhere across the void, lined up with Earth. For a moment. For milliseconds. A precise beam of energy raced across 500 million light-years of space, and rang like a bell in our detectors. Each pass triggered one flare. A brief but perfect signal. Focused. Timed. Predictable. A cosmic lighthouse, spinning in rhythm, sweeping the sky with silent light. But here's the chilling part: this system is not eternal. It's doomed. Because the black hole isn't just emitting, it's devouring. Every moment, it's stealing more mass from its companion. Feeding. Growing. The orbit tightens. The balance shifts. And eventually, the companion star will be stripped away entirely. Consumed. And when that happens, when the dance ends, the signal will vanish. What we're seeing now is a snapshot. A cosmic coincidence of alignment, physics, and timing. A fleeting arrangement that exists for only a blink in astronomical terms. Out of billions of years, we happen to catch this window. This moment. This heartbeat of an unraveling system. That's what made this discovery so extraordinary. Not the black hole. We've seen those before. Not even the FRB, those have been recorded hundreds of times. What made this special was the precision. The stability. The clockwork behavior of something so inherently chaotic. It mimicked intelligence. It faked design. But it wasn't artificial. It was nature showing off. Nature, it turns out, can write poetry. Not in language. Not in symbols. But in pattern. In gravity. In time. This was the universe expressing itself in rhythm. In structure. In a kind of order that forces us to rethink what order even means. For decades, we've searched the stars for meaning. For signals. We've waited for a call from the void. But maybe we've misunderstood the nature of the message. Maybe we've already been receiving them. All along. Not from alien civilizations. Not from distant intelligences. But from the universe itself. Because sometimes, intelligence isn't required to produce beauty. Sometimes, the laws of physics write their own music. And if we learn how to listen, truly listen, we may discover that the cosmos is filled with voices we never knew how to hear. By now, the pieces were coming together, the periodic signal, the location, the behavior. The source of the cosmic heartbeat was a celestial duet, the binary system featuring a collapsed stellar remnant and a doomed companion. Binary systems are common across the cosmos. In fact, most stars are born in pairs. But when one of them dies violently, it doesn't vanish. It evolves. What remains is a neutron star, or worse, a black hole, an object so dense it bends light and time. In this case, the dead star was almost certainly a black hole. Small. Active. And feeding. As the living star orbited too close, its outer layers began to peel away. Drawn by gravity, gas spiraled into the black hole, forming an accretion disk, a swirling halo of matter heating up to millions of degrees. Then, the phenomenon that changed everything, relativistic jets. Under specific conditions, black holes eject matter not inward, but outward, at nearly the speed of light. These focused plasma streams shoot from the poles. And when one of them happens to align with Earth, even for milliseconds, we detect it as a fast radio burst. The answer lies in orbital geometry. The companion star and black hole aren't perfectly aligned all the time. But once every 22.4 days, their orbital paths cross just right. The jet, normally aimed elsewhere, sweeps past Earth like a lighthouse beam. Each pass triggers a single, sharp burst. A brief signal, focused, timed, consistent. The ultimate cosmic clockwork. But here's the chilling twist, this system is doomed. As the black hole feeds, it steals mass. The orbit tightens. Tidal forces grow. Eventually, the companion star will be consumed entirely, and the signal will vanish. This cosmic metronome is temporary. A transient lighthouse. And that means we are witnessing it in a fleeting window, a cosmic instant out of billions of years. This wasn't just about detecting a black hole. We've seen those before. This was about witnessing an incredibly rare alignment. A system so precise, so well-tuned, that it mimicked intelligence. It was nature writing poetry in physics. It forces us to reframe what we consider a message. Maybe intelligence isn't required to produce order. Maybe the universe itself speaks in patterns. For centuries, we've searched the stars for meaning, for signals. And perhaps, we've been receiving them all along. Not from aliens. Not from gods. But from the very fabric of nature, playing out its laws, across time and space, in rhythms we are only now learning to hear. It began as a flicker. A whisper from deep space. barely a breath against the roar of the universe. A pulse, too short to notice, too faint to matter. And yet, it would become a revelation. This single signal, repeating steadily across 500 million light-years, didn't just register on our instruments. It echoed through the halls of science. It shook the pillars of assumption. Because its significance didn't lie in its strength, or even in its clarity, but in its meaning. For decades, we believed the distant universe was governed by chaos. That beyond the delicate balance of planets and moons, everything descended into disorder. Black holes were thought to be monstrous vacuums, devouring matter in random bursts. Star systems behaved with little regard for rhythm. High-energy cosmic events were assumed to be unpredictable, spontaneous fireworks in the dark. But then came the 22-point-per-day signal. Steady. Repeating. Measured. It was not a scream, not a cry, not a voice. It was a pattern, undeniable, consistent, mechanical. And with it came a challenge. A direct affront to one of science's oldest axioms, that structure implies intelligence. We've long looked to the stars expecting that where we find order, we will find minds like ours. The search for extraterrestrial intelligence, SETI, has spent decades scanning the sky for regularity, narrowband signals, repeating sequences, patterns that could only be created with intent. Prime numbers. Modulation. Message formatting. Because those are the things we humans use to signify thought. But what if nature doesn't need intelligence to produce those things? What if the universe is capable of creating near-perfect symmetry entirely by accident? This signal forced us to rethink what a signal even is. Not everything that repeats is deliberate. Not everything that appears encoded is, in fact, a message. And yet, the line between communication and coincidence is thinner than we ever imagined. What if we've already intercepted intelligence, or what we thought was intelligence, and it turned out to be something else? What if we're hearing the universe speak, not in language, but in function? In systems? In cycles? In the recursive heartbeat of its own machinery? Because that's what this binary system revealed, not a voice, but a mechanism. A natural machine. One capable of generating precision that rivals our best clocks. For the first time in history, astronomers weren't just observing the sky. They were predicting it. To the second. Each burst of radio energy became a celestial timestamp. A known event. A fixed point in time across the vast unknown. Telescopes were aimed in advance. Instruments calibrated. Data prepared, not in reaction, but in anticipation. It was like knowing the exact moment lightning would strike. It turned the chaotic into the knowable. The random into the reliable. We weren't just seeing the universe. We were syncing with it. And this changes everything. Because it opens a new era of observation, one not based on passive watching, but coordinated action. It allows for collaboration across continents. For multi-wavelength synchronization. For real-time study of events millions of light-years away. A level of cosmic precision previously thought impossible. But beyond the science lies something deeper. Something harder to quantify. The emotional weight of hearing such a clean, deliberate rhythm echoing across 500 million years of distance is profound. It creates a sense of connection. Of shared timing. Of communion with something impossibly vast and ancient. It humbles us. Because it tells us the universe is not silent. It is not asleep. It is speaking, constantly, not in words, not in symbols, but in motion, in energy, in recurring moments of light and sound and silence. And it raises an even greater question: what else are we missing? How many other systems out there are ticking in perfect rhythm, unnoticed? How many patterns have we overlooked because we weren't listening the right way? How many coincidences are not coincidental at all, but signatures of structures far deeper than we yet understand? Strangely, our ancestors may have grasped this before we did. For thousands of years, ancient civilizations looked up at the sky and saw a clock. They mapped the stars, tracked the planets, worshipped the cycles of sun and moon. They believed in divine order, that the heavens moved according to purpose. Modern science dismissed much of this as superstition. We called it myth. We replaced gods with math. But now, a dying star and a feeding black hole, bound by gravity alone, have become the most precise timekeeping mechanism we've ever discovered outside Earth. Perhaps the ancients weren't wrong to see patterns in the sky. They just lacked radio telescopes. What may be most astonishing about this discovery isn't what it revealed about the binary system, but what it revealed about us. It became a mirror, reflecting back our curiosity, our need for meaning, our desire to decode, to explain, to understand. It forced us to confront our assumptions that beauty requires a designer, that complexity demands consciousness, that regularity must arise from reason. But the cosmos doesn't bend to our expectations. And sometimes, the universe creates masterpieces entirely on its own. Even so, we still listen. Because part of us still wonders, what if? What if next time, the signal isn't accidental? What if the next rhythm comes not from a black hole, but from a mind? Would we even recognize it? So when you look up at the night sky, when you stand beneath the stars and feel the weight of silence, remember this: somewhere out there, in a galaxy so distant its light left before Earth formed its first forests, a black hole and its dying partner continue to dance. Their orbits tight, their jets aligned, their rhythm perfect. They are not calling to us, but they are reaching us. A rhythm, a whisper, a secret of the universe, unfolding in silence. We live in a universe of vast distances and ancient light, a cosmos so expansive, so old, that everything we witness today is already history. A universe where time stretches and folds, where light from a distant star can travel for 500 million years before touching our eyes, and where even the briefest flicker can carry a story older than Earth itself. In such a universe, most things pass unnoticed. Most signals are swallowed by noise. Most events vanish into the dark. But sometimes, just sometimes, we catch a glimpse. A pattern. A whisper that doesn't belong. And in that moment, our instruments, our equations, and even our imaginations fall short. Because we're not just looking at data. We're looking at mystery. What began as a peculiar anomaly, a single fast radio burst, soon became one of the most precisely timed cosmic events ever recorded. Not a message. Not a beacon. Not a greeting from the stars. But something far more subtle. And perhaps, far more meaningful. A dying star and a hungry black hole, locked in a gravitational embrace, sending out rhythmic, perfect bursts of energy into the void. No technology. No design. Just physics. Beautiful, cold, indifferent physics. And yet, this discovery changed everything. It lit a fire under the world of astronomy. It proved that predictable, repeatable, and structured signals could emerge from the depths of nature, not from civilization, but from collapse. It forced a shift in how we search, how we listen, and what we assume is meaningful. Telescope networks began coordinating more closely. New instruments were fast-tracked. The upcoming square-kilometer array, the most powerful radio observatory ever conceived, will scan the heavens with unprecedented sensitivity. It will hear whispers we've never been able to detect. And if this binary system isn't unique, if others like it exist, as they almost certainly do, we may soon find ourselves overwhelmed by pattern. What was once rare may become common. What was once considered anomalous may be the universe's most ordinary poetry. We are, in a very real sense, entering a renaissance of radio astronomy. A moment where we no longer strain to catch isolated blips. We are beginning to hear the symphony. Faint chords, building slowly. Not composed, but coherent. Not artificial, but no less exquisite. But this wasn't just a story for scientists. It reached far beyond academia. It captured the public imagination. The headlines came quickly: alien signal detected, evidence of extraterrestrial intelligence. And though the truth was more grounded, more gravitational, the awe remained. Because it felt intentional. Deliberate. It felt like a message, even though it wasn't. And maybe that's what made it so powerful. This story wasn't just about a signal. It was about perspective. About what we expect to find when we look into the dark. About how quickly we assign meaning, and how gracefully we must learn to let that meaning evolve. It reminded us that wonder is not reserved for myth, or fantasy, or fiction. Wonder lives in real stars. In real systems. In phenomena that follow the rules of the universe, and yet defy our expectations of what those rules can create. It reminded us of the questions, and of the humility required to accept the answers. Because sometimes, the answer is not someone is calling. Sometimes, the answer is the universe is moving. And we happen to be listening at the right moment. More than anything, this discovery reignited something we've slowly been losing, a sense of cosmic mystery. For a new generation, raised on algorithms, simulations, and simulations of simulations, this was a reminder that space still holds secrets. That not everything has been charted. That not every sky is mapped. That above our rooftops and city lights, a vast and uncharted ocean of phenomena continues to unfold. This was more than data. More than science. It was awe. The astronomers detected a mysterious signal. They were shocked when they learned its origin. But what astonished them even more was what it revealed. Not about black holes. Not about binary systems. Not even about radio bursts. But about the universe. And about us. That we still listen. That we still ask. That we are still, despite everything, capable of wonder. What if the next signal isn't from a black hole? What if we're not alone? Subscribe for more universe secrets. If this video made you feel a little smaller, or a little more curious, give it a like, subscribe, and drop your thoughts below. What do you think we'll find next? And stay tuned, because the universe isn't done whispering.